Recommendation systems play a crucial role in allowing users to navigate efficiently the vast number of options and information that is currently available. Nevertheless, these systems are mostly known for their services and impact on individual users, often neglecting the possibility of picturing their services for groups of people. To fill this gap, designers and practitioners are increasingly implementing the systems in various cooperative and social computing domains. The groups of recommendation systems often consider the individual preferences of each member of the group, their social and behavioral aspects, among other clues to calculate good algorithmic recommendations, despite the different levels of heterogeneity within the group. In this context, previous research has reported how personalized recommendation systems produce negative experiences for their users, such as invisibility, anxiety and panic, bias in personalization processes, lack of control and minimum feedback, low algorithmic awareness, and a long list of ethical issues such as discrimination and challenges to user autonomy. However, to our knowledge, there is no comprehensive meta-analysis that takes a human-centric stance to determine interaction design strategies for group recommender systems, focusing on the specific problems associated with these systems, such as transparency, justifications, control, diversity, group formation, or achieving a final consensus of the group. For this reason, we decided to provide such a systematic review, offering designers and professionals the necessary outlet to address these issues and imagine new ways to interact with group recommendation systems. Our systematic selection process resulted in a final corpus of 142 academic products. Following a systematic coding process for the corpus, we used descriptive statistics and thematic analysis to identify current trends and gaps in scholarly research regarding our research questions. Based on our findings, we propose a comprehensive typology containing 28 different interactive design strategies for group recommendation systems in 6 different areas: user and group profile transparency, justification of the recommendation, control, diversity and serendipity, group formation, and achieving a final group consensus. The first area is user or group profile transparency. This variable brought 5 different interaction design strategies where the system represents the profile of the user or group. The first one is feature-based rating that shows the current weight of each characteristic considered to create the recommendations. The second is recommended item-based rating that exposes the current weight of each recommended item to be included as a recommendation. The third is based on iterative criticism that shows how the members of the group have iteratively criticized each of the recommended elements. The fourth is based on visualization. The interface shows different visualizations that represent the current preferences to create the recommendations. And the fifth is based on keywords, where the system has a predefined set of keywords to represent the user or group profile. The second area is justification of the recommendation. This variable showed 3 interaction design strategies. The first one is text-based justification. The next one is the coordinator-based justifications, where the system allows the user to justify each recommendation manually. And the last one is justifications based on visualizations. The system justifies each recommendation with graphs and visualizations. Our third area is control. This variable is divided into 2 main groups. The first group is control over recommendations. The system allows the user to control and offer feedback on the recommended articles. Here, we found 3 strategies that the system offers to control: by number ratings, by binary ranking, for example, with a binary yes or no system, or dislike and dislike. And the third one is by ranking, where the user is able to rank the recommendations in ordered sequence of likelihood. The second group is control over user group profile. The system allows the user to control the user or group profiles, changing their preferences or current weights to create the recommendations. Here, we found 3 strategies where the system offers to control in different ways. By personal restrictions, where the system follows personal preferences for the characteristics of the recommendations. By filtering restrictions, where the system adds filters to the possible recommendations. By weight of the members of the group, where the system offers to control how relevant each group member's profile is to produce the recommendations. And the last one is by using 2 or more areas of the previous control strategies. The next area is diversity and serendipity. We found only one interaction design strategy, that is by recommending filtering based on unknown elements that allow users to explore their options besides the usual consumed elements. Our fourth area is group formation, and it contains 6 interaction design strategies that allow users to form their groups. We have a social media strategy, where the system uses social media platforms to invite other group members. The second strategy is the admin-centered, where one admin user handles all group formation, features, and decisions. Opposite to this one is the horizontal strategy, where all users handle group formation and decision. The fourth one is the discoverable team strategy, where users can find groups and join them. Another one is the automatic decision strategy. The system automatically creates a group of users based on their preferences. And the last one is other strategies, where the system uses a diverse set of options to form groups like tag reading, logging in simultaneously, face recognition, QR codes, login, and others. Finally, the last area is achieving a final group consensus. The interaction design approaches we discovered in this group allowed users to achieve a final decisions about the recommended items. These ones are summarized as follows. Democratic approach. All users vote for their preferred recommendation and the most voted option wins. B2Power approach. A user has the last word to choose between the recommended items. Mutual agreement approach, where the system provides features for users to discuss on their preferred items until group members reach a mutual agreement. Third-party approach, where each member of the group delegates the final decision on the recommended elements to a third party. Filtering and classification approach, where users can filter by reducing the number of recommendations until the group reaches a final decision. Finally, our review also identified several opportunities to explore group recommender systems and its implementation in novel contexts. We break these opportunities down into application domains and devices. We found that many articles dealing with tourist routes and points of interest group recommendations only deal with leisure activities, but there are no studies dedicated to exploring route recommendations for more serious purposes, such as commuting or work-related route recommendations. We also found no approach exploring tangible user interfaces or more material ways to interact with group recommendations, offering a new approach to study this research context. In addition, we believe that there is still a research gap that invites us to systematically explore current analysis and research methods that include users in the group recommendation system interface design process. Considering that 72% of the academic products of our final corpus reported at least one user study with a strong tendency towards quantitative and behavioral approaches, it seems urgent to encourage the active inclusion of users to design the interaction of group recommender systems with various analysis methods and research. Lastly, we see an opportunity to include more qualitative approaches that could expand current notions about group recommendation systems interaction and uncover new areas of design. A human-centered approach that engages users early in the design process must be the norm for this domain to achieve proper interfaces.